Caloric restriction, defined as a long-term reduction in total energy intake without malnutrition, is one of the most extensively studied interventions for extending lifespan and promoting cellular rejuvenation across a variety of species. One of its central mechanisms is the activation of autophagy, a vital self-cleaning process in which cells break down and recycle damaged components to maintain homeostasis. By consistently lowering caloric intake, insulin and insulin-like growth factor 1, IGF-1 levels are reduced, signaling a metabolic shift that mimics nutrient scarcity. This decrease in anabolic signaling leads to inhibition of the mTOR pathway and activation of AMPK and SIRT1, together creating a biochemical environment conducive to autophagy. Over time, this promotes mitochondrial quality control, reduces protein aggregates, and limits chronic inflammation, hallmarks of aging and degenerative disease. Interestingly, the body doesn't just survive under caloric restriction, it becomes more efficient, resilient, and metabolically flexible. Autophagy, in this context, plays the role of an internal janitor, tidying up intracellular clutter and allowing cells to function more optimally with fewer resources. While caloric restriction reduces overall energy intake, it must be carefully designed to avoid nutrient deficiencies that would otherwise offset its benefits. A diet low in calories but high in micronutrient density is essential to support autophagic processes and maintain systemic balance. Trace minerals like zinc and selenium are particularly supportive in this regard. Zinc is a cofactor in numerous enzymatic reactions and plays a direct role in DNA repair, immune function, and cellular signaling, all of which intersect with autophagic regulation. Selenium, on the other hand, contributes to antioxidant defense through its incorporation into glutathione peroxidase enzymes, reducing oxidative stress that might otherwise accumulate when autophagy is insufficient. Ensuring adequate intake of these and other micronutrients helps cells carry out detoxification and repair while undergoing energy limitation, making caloric restriction a regenerative rather than depleting process. Whole, unprocessed plant foods, such as leafy greens, sea vegetables, nuts, seeds, and legumes, offer a nutrient-rich foundation for a calorie-reduced diet. These foods are naturally low in energy density while being packed with vitamins, minerals, and phytonutrients that support mitochondrial efficiency and the removal of damaged cellular components. For instance, cruciferous vegetables like broccoli and kale contain sulforaphane, a compound that not only activates phase 2 detoxification enzymes, but also has been shown to influence autophagic flux. Similarly, berries and dark-colored fruits provide polyphenol like anthocyanins and ellagic acid, which modulate stress response pathways that overlap with autophagy-related genes. A notable advantage of caloric restriction over more extreme fasting is its compatibility with long-term daily routines. While intermittent fasting involves distinct periods of complete food abstinence, caloric restriction allows for regular nutrient intake spread throughout the day, which may be more sustainable for certain populations, especially older adults or those with underlying metabolic conditions. Importantly, caloric restriction does not mean deprivation. It means prioritizing quality over quantity. Small, nutrient-dense meals that stabilize blood sugar while maintaining low insulin output create the perfect internal conditions for autophagy to unfold gradually and continuously. The long-term effects of caloric restriction on cellular health are now being supported by human studies, including findings from the calorie trial, comprehensive assessment of long-term effects of reducing intake of energy, which demonstrated improved biomarkers of aging, reduced inflammation, and enhanced insulin sensitivity in healthy adults following moderate caloric restriction. These systemic improvements align with what has been observed in model organisms: greater cellular efficiency, fewer age-related diseases, and even potential lifespan extension. Ultimately, caloric restriction represents more than a diet. It is a metabolic reset that encourages cells to prioritize repair over growth. When coupled with a thoughtful, micronutrient-rich dietary strategy, this approach may offer one of the most practical and scientifically grounded paths toward activating autophagy and promoting longevity. It doesn't rely on extreme behaviors, just consistent moderation, smart food choices, and an understanding that a little biological stress can lead to profound cellular renewal.